Hello, my name is Frank Hellman, and I'm a researcher at the Potsdam Institute of Climate Impact Research. We have built a small website to illustrate the type of work we're doing on the dynamics of power grids, and I would like to walk you through it briefly now. On the left-hand side, you see a technical description of the simulations that we do, as well as our publications on the stability of power grids. On the right-hand side and in the middle, you see a visualization of such a simulation that underlies our research, together with some toggles and buttons that allow you to control the simulation. What we are simulating here is an alternating current power grid. In an alternating current power grid, power rides a wave in a particular direction. Here, the power grid is going at 50 Hertz. We're only illustrating a 1 Hertz version of it, and power rides from the south to the north along a wave that travels through the network. Even though the individual nodes are pulsating and rotating at 50 Hertz, the power that flows on the lines is actually completely static. In our visualization, this power is illustrated by the thickness of the lines. The simulation allows you to perturb this stable wave that transports energy through the network by clicking on individual nodes. When you click on a node, the power that flows from it into the network changes. It starts fluctuating and the frequency deviates from 50 Hertz. Typically, such fluctuations break down very quickly. The power grid is very stable and they're damped away immediately without causing much problems. However, if you perturb some nodes, you can see that non-local effects do take place. Even though I'm perturbing this node, other lines far away from it might start fluctuating as well. If I reduce the amount of damping in the system, that is the amount of energy available to control these fluctuations, we can see rather dramatic effects. The fluctuations in the power flows spread through the network, and bit by bit they destroy the stable wave that transports energy through the network. Our research focuses on the question which nodes are particularly vulnerable and what type of perturbations can destabilize the power system. This visualization allowed us to illustrate these effects to great effect at the Long Night of Science. Clearly, this is not a self-contained exhibit yet. However, we would like to develop it in that direction. In particular, what we see as missing is a more detailed explanation of what it is you see. The explanation on the left-hand side is aimed at theoretical physicists, and we need to write one that will be more appreciable to the general audience. Further, we would like to allow the user to also add or delete lines in order to show how the network structure affects the dynamical properties. Finally, it would be very nice to prepare a set of scenarios that demonstrate the various effects that can occur when perturbing nodes, rather than having people just randomly play around with the various, not very self-explanatory values in the system. Thank you very much for listening, and that's all.